Welcome back everyone, and in today's video we are going to solve another problem from trigonometry, and it's a different one from the previous problem that we have done in the last video. So make sure you concentrate and make sure you listen carefully so that you can get a better understanding on this problem. So let's move on to solve this problem. Okay, so the question is that if angle A and angle B are acute angles, such that cos A is equal to cos B, then show that angle A is equal to angle B. So let us try to solve this question. Okay, first let us sketch a figure of this question so that we can get a better understanding of the question. So suppose we have two right angles triangle, and this acute angle let us consider to be angle A, and let us write this point as point P and this as point Q. And the other triangle, let us consider that this acute angle is angle B, and this, let's see, XY, angle XY. So we have two right angle triangle where angle A and angle B are acute angles. So what we have to show? We have to show that angle A and angle B are equal. So let's write from the given part. So the solution, let us start. Cos A is equal to cos B. That is the given part. And from here, from the first figure, if you look at cos A is equal to AP by AQ. Since cos is the base by hypotenuse, so cos will be AP by AQ, which is equal to cos B. Cos B will be similarly base by hypotenuse, so BX by BY. That will be equal to BX by BY. So here let us cross multiply. This BX you multiply towards the left and AQ towards the right. So what will you get? You will get AP by BX is equal to AQ by BY. And let's say that this ratio is equal to some constant value. Okay, let's just say that. Let's write this equation 1. So now, as we can see here that AB by BX or AP by BX is equal to AQ by BY is equal to AQ by BY. Let us try to find out what will be the value of PQ by XY. If they are equal, maybe we can draw a conclusion from that part. Now, PQ by XY is equal to PQ. If you apply Pythagoras theorem, then this PQ acts as the perpendicular, and similarly XY acts as the perpendicular. So we can write by Pythagoras theorem, we just apply here. You can write AQ square minus AP square. And similarly, in the denominator, XY can be written as BY square minus BX square. So that will be equal to, so AQ from equation 1 you'll have K BY, so K square BY square, and AP square from equation 1 will get BX taken to the right side when there is K, so AP will be KBX, K square BX square. So just write the same thing in the denominator, BY square minus BX square. That will be equal to root over K square BY square minus BX square. Here also the same thing, BY square minus BX square. And as you can see here that this constant K, there is a square. So that square can move out from the square root. Since the square and the square root can be cancelled out for the value of K. So what do we have? PQ by XY is equal to K. And what is left in the square root will be BY square minus BX square. So similarly, the denominator will remain same, BY square minus BX square. So as you can see that this term and this term can we cancel out this one and this one? Since they are both equal, we will get equal to k only. If you look here from the last part of the equation, you'll find out that pq by xy is also equal to k. And this k from equation 1 is equal to ap by bx is equal to aq by by. Then what do we do? If we can substitute in place of k by pq by xy, we can write that, therefore, ap by bx is equal to aq by by is equal to pq by xy. Since all these three ratios are equal to k, so we can write in this way. And if you write in this way, you'll see that these sides of these two right angles triangle are proportional. That is, ap by bx is equal to aq by by is equal to pq by xy. Then we can say that by SSS similarity. So we can continue with here. By SSS similarity, that is the one that we have applied from the previous chapter, that is chapter 6. We applied the theorem which is in chapter 6. And by SSS similarity, what can we say? Triangle APQ is similar to triangle BXY. And since these two right angle triangle are similar, then we can conclude by the definition of similarity, the corresponding angles must be equal. Then we can conclude that angle A is equal to angle AB. Implies angle A is equal to angle B. Hence, that is how we show that angle A is equal to angle B. I hope you have understand this question that we have solved in today's video. And if you have any doubt, any feedback or any question, please feel free to drop it in the comment below so that we can make better videos in the upcoming days. Thank you for watching. God bless you and stay safe.